I had a hobby too. Mine happened to be guns and ballistics, and I studied guns and ballistics as much as I could, and I wrote an article about high velocity.
So out of all my years working at Weatherby, the last 5 have been some of the most exciting. Working with Adam, with him running the company.
And to think that I get the opportunity of carrying on my grandfather's legacy 75 years later here in Sheridan, Wyoming, I mean, it really is a dream come true.
Oh, I'm home. Thank God I'm home.
On our mark, the Weatherby Podcast.
All right, on our mark, the Weatherby Podcast, we've got some special guests in here today. Adam, you're fresh back from Africa.
Sure am. Yeah. Had a heck of a trip.
Not even been back in the country for a week.
Mm-hmm.
And you got to play with a variety of things over there, but some hammer bullets.
I did. Yeah. Last year, last fall was my first experience. Took a mule deer with a hammer bullet, and then took it all the way over to Africa, which was a testing grounds for my grandfather Roy Weatherby to test bullets and velocity. And I can see getting back why that was a testing grounds. It's so abundant with game, thick hides, their vitals are small, you got to make good shots, but you do have to have really good terminal performance. So it was fun. Used a variety of bullets over there, but did take a couple animals with the hammer bullet. And so today we have actually the brains behind the hammer bullets operation with us.
Hammer bullets with us.
Yeah.
Well, it's funny you say a testing ground. It's been the same thing for us in Africa. We can shoot there like we can't even think of shooting here.
Yes.
We go out there with a group of guys, and in a week we can have 50 animals.
Yeah. Really test it out.
And see the terminal performance, which is it's terrific.
Before we get too far in, Steve, though, you're Steve Davis.
Yes, I'm Steve Davis.
You're the janitor at Hammer. What do you do there?
I do that too. So I'm one of the owners. So Bryan and I are partners. We both own the company. Started out 2015, I guess.
When the company was formed.
So that's Bryan speaking. So we got a total of Steve and Bryan in here.
Yep, I'm Bryan.
So. Yeah. Before we get in, I want to talk about how you guys came up with what you guys do, but we're excited to have you guys in because we kind of started our relationship a year and a half ago, somewhere in there. Mm-hmm. And our ballistics team, as soon as we started playing with some of your stuff, immediately we're like, hey, these are something's a little different going on here.
Sometimes we joke that our ballisticians are like paid commission by you guys because every time we start to talk about a new load, they hammer this and hammer that. Yeah. I'm like, guys, you're smoking the hammer stuff. It's crazy, but it's neat. You guys are right up in Montana, right across the border. You're making premium bullets. We're a premium manufacturer. It's been a great partnership, and looking forward to diving in today to hear more about your guys' inception, how things got going.
Yeah, we kind of owe it to John, I guess.
John Baumgartner.
He
shout out.
He sent me an email and said, "Hey, I've been playing with your bullets on my own," and he says, I kind of got this out in front of the marketing. They don't even know I'm talking to you, but can you send me some bullets to work with?
he may have cheated the system a little in a good way. I'm glad he did it.
And so we kind of owe it to him. So I'm like, sure, So I sent him some bullets, and he messed with them, and then I think finally convinced the powers that be that, hey, maybe we should look harder at these hammers. And then a few of you guys came up and visited us. That was about a year ago. Yeah. And now I think we have a nice relationship now, and it's exciting for us.
Were we the first major brand that you guys are factory loaded in?
Yes.
Yeah.
We went 2019, the last SHOT Show before the COVID.
Yeah.
We went there with the intent to find an ammo manufacturer, and left there figuring if we're going to have ammo, we'll have to do it ourselves.
Yep. Oh, no kidding.
Everybody we talked to is kind of on the race to the bottom. If you can't do it cheaper, we're not interested. And I'm like, well, geez, I'm on a different racetrack. I'm trying to race to the top, not to the bottom. So it's just, and we started thinking, well, geez, if we tie in with an ammo manufacturer and they make something that's not good, and then we get those those Hammer bullets don't work very good. Well, the last
don't
thing
want
I
that,
wanted,
yeah.
last thing I wanted to be is saying, well, the Hammer bullets are good, but that ammo manufacturer is not any good. So that kind of thought was where we decided, oh, geez, we're going to have to do this ourselves if we're going to do it, But then John came along and had the discussion, and we just got to see the facility, and it confirmed for us what we already thought we knew, which quality is paramount here, and the efforts that are made to make sure that things stay consistently good all the time. I'm super pleased with what we've seen today.
Good. Well, I think it is a good fit. I mean, we always say the words ballistic superiority. When my grandfather started the company, we were actually an ammo manufacturer before, an ammo loader, with our cartridges, before we ever made guns. And people, look to us as a gun maker, firearm maker, but, kind of premium rifles and shotguns. But we're here because exactly this story, premium ballistic performance in a hunting environment is our bread and butter. It's what made us who we are.
Roy thought there was a better way, which was velocity, and that ties in with what you guys do for sure. But what drove you guys? Were you manufacturing engineers before this? Like what how did you decide, we're going to start making lathe turn copper bullets?
Well, go ahead, chew that one off.
Oh my. You're better at it.
Yeah. Well, we were those weird guys, and I don't know. I think we kind of thought everybody was like us, but we were those guys that would be at the range, lining up milk jugs and catching bullets to see what they do. And we were, I guess, on the quest to find the better bullet. Which there's lots of guys that are like that. I get to talk to them daily when they call. It's like, hey, I've been looking for this, and I've been using that, and I'm not seeing what I want. And I'm like, well, you're the same guy that we were, looking for. We just wanted a good bullet that would arrive on game, make it nice and dead without blowing it to pieces. I mean, we grew up, when I was taught to hunt, don't shoot too close to the shoulder. We want to eat this. We don't want to lose any meat.
Right.
If our families didn't do well hunting, we both grew up the same way. We didn't have a lot of meat.
Right.
Hunting was a bit, it's always been a recreation, but it was a necessity as well. So, making a shot on an animal, making a good shot, and losing a shoulder, even though we didn't hit it, that's what we were trying to get away from.
Right.
And in that process, we found, copper bullets, and liked how they work. They're not as destructive to meat. They don't blow out radially like the lead does. And so we found that, and we tried this brand, that brand. We tried, everything had some sort of an issue, and in the end, we wound up getting a lathe and putting it in my garage, and we started making bullets. At that process.
And when was this, Steve?
2014, 15, right in there.
Okay.
It took us about a year of tinkering around trying to learn how to do something with a lathe because we had never done it before.
Right.
So what were you doing before?
I had a landscaping company, and
I did construction.
So
Finished carpentry.
Perfect tie-in to lathe turn bullets. Okay.
Well, my college background was AutoCAD.
Okay.
So I had
so you had some background.
So
just in AutoCAD, nothing about bullets, nothing about engineering of that kind of stuff. But
not about turning AutoCAD into
Exactly.
G-code and
Exactly.
No.
Okay.
Yeah.
But that's all I do now.
Yeah. So, fortunately, Bryan had that background in the CAD. We'd gotten this machine, and we had a guy that we brought in that was going to be our ballistician and our programmer and our machinist and all those things that we weren't. And it didn't work out. And then Bryan and I basically had to figure it out ourselves. Which is, so our background kind of ties in because, we both grew up kind of agriculturally and then worked in trades, and in those types of world, you figure it out.
You figure out how to
if you got to get something done, you figure out how to make it happen. And so there we sat with this machine in the garage, and
how'd you even pick that first machine? Did you just get on eBay?
The guy that we knew.
The guy that we knew, that was his recommendation
Yes.
of what we should do. And that machine, it did us well. It doesn't owe us a thing. We still have it. It's not doing anything now. It's taking up its little space, and we keep trying to think of things we could do with it. But when we moved from that machine to the big Swiss machines that we use now, we couldn't make the Swiss machines duplicate what we were doing on the little 2-axis lathe. Partly because we never had it set up correctly because we didn't know how. Right. So, yeah, and then we're getting the new machines and we're measuring, and it's like, this is different. It's not the same, But in the end, we had to go, okay, well, that was yesterday. Today, this is today.
Right.
And part of it is just this difference in how the machines work. There's no tool deflection, and we talked about geeking out, but it's more consistent. It does more precisely what you ask it to do than the little 2-axis lathe would
Sure.
do. So that was part of it that just changed. Fortunately, that stuff, it's so minute nobody really could tell. I think some of the bullets changed like a grain in weight and things like that.
Right.
But
so did you just get on Amazon and just buy some copper? Like how'd you even figure out where to go? And I guess there's probably different types of copper.
Yeah, more than you can even imagine. There's all these alloys, and not knowing, if we'd have known then what we know now, I don't think we'd ever tried.
No.
No kidding.
We wouldn't be here today.
No, we wouldn't.
Not a chance.
No, because we just thought we'd get good pure copper. The purer the better, right?
Yep.
So that was our quest in the beginning, was to find the most pure copper we could get a hold of, and we'll make bullets out of it. It's got to be great. And it didn't work. We could make the bullet.
Sure.
That's.
But it didn't perform.
And terminal performance. So what it does when it hits, that's been our guiding principle from the beginning. Everything else is secondary. It has to do what it's supposed to do when it arrives, and if it doesn't do that, then we're not going to put it out. And so those first coppers that we tried, they would work well at high velocity, but low velocity was the issue. Getting a bullet to perform on impact at low velocity, that's where the rubber meets the road.
Okay.
But we were after something that would perform low and high.
Yes.
And be consistent. And
what do you consider low, and what do you consider high?
1,800 feet per second, and the upper limit there is nothing.
Yeah, we haven't
found an upper
We haven't
limit.
had a.
Yeah, which has been good for our partnership, because sometimes bullets can tend to just pencil through at high velocities, but we've noticed with yours a real consistency across the velocities in upon penetration. So
Yeah, when we found the copper that we currently use, it consistently works throughout the range of velocity. And like Bryan said, we test down to 1,800.
Okay.
And it's kind of the only place we inflict our opinion on our customers. We feel like 18 is a good minimum for good terminal performance.
And when you say good terminal performance, what are you, because I know everybody's definition of that is a little bit different. What are you guys looking for that bullet to do upon impact for you to say that's success? And maybe Bryan hasn't answered any questions.
Yeah, go,
he
Bryan.
keeps pointing.
Pointing.
Okay. Yeah.
Well, so up on the impact, the first thing we want to do is, of course, just to open the front of the bullet. And that's because of the moisture that gets it to the hollow point. And after that, we want the petals to shear off, and we want them to shear off down at the hollow point depth. And then we can control the weight retention when that happens. And so when that does happen, you also get a wound channel from the petals that actually peel off in the front. And they do their own damage as well going through the animal, which is more than what we ever realized. Whenever we first started, we didn't even take into consideration the nose petals doing damage.
We just wanted them off.
We just wanted them off.
We just knew we wanted that nose off of there. What we wanted that bullet to do is transform from its ballistic form to its terminal form, and with terminal form, kind of like a dangerous game bullet, we wanted that frontal of the bullet to be flat and square. Kind of.
Okay, that's what I was going to ask. Is why exactly do you want
We
it
want
off?
it flat.
That flat square, not a rounded mushroom. That flat square, even though maybe it, the double caliber mushroom, that's kind of the bellwether.
Right.
But that rounded form kind of parts its way through the soft tissue, versus a flat square, as it goes through, it radiates perpendicular to the direction it's going. So even though it may not be as big, it'll create a larger permanent wound because it's pushing out
cutting more.
Yeah,
It's all the
know,
energy is going directly out.
Yeah.
So
Yeah.
it's not
So
weaving around.
Sure.
So what did you find when the pedals come off and do that? They create their own damage. But let's just talk about the bullet in its form at that point that's pedalless, if you would, with more of that blunt or square thing versus an all copper bullet that would do more. The pedals would retain on their higher, overall weight retention of the original bullet in its form in a mushroom, that more traditional. What do you find in the difference between the wound channel of what your bullets are doing versus that?
It's significantly bigger from start to finish.
Okay.
So the initial shock, that initial large wound from opening and shedding, that shock is very big. Bryan said, we kind of discounted the pedals from the start. Our terminal performance goals were based on a physics paper called Shooting Holes in the Wounding Theory. It's a great read for a geek. It's an all-weekend sit down and do nothing but read a physics paper. But if anybody's interested in terminal performance and why and how it happens, it's worth the read. And so that was one of those geeky things that I did long before we started making bullets, was read this guy's paper. And so that's where we determined our goals of what we wanted a bullet to do. Was from that physics paper. And
we had shot copper bullets too that did that. So we've seen the terminal performance.
Yeah, so
in the pedals coming off and the dangerous game bullet.
And in our own personal hunting, we'd seen good terminal performance. So the definition of the good terminal performance, for me, that's quick, clean kills.
Yeah, absolutely.
And that's that. As hunters, that's what we want. Slow kills they're not good. They're not fun. It's just not what we want to see.
No one wants that. Makes you more nervous, everything.
Yeah. So the quick, clean kill, that's my definition of good terminal performance. Technically what the bullet is doing, that we don't consider the bullet doing what it should do unless it's fully opened and shedded.
That's correct.
So if we held on to the pedals, we would almost consider it failure. I mean, the bullet opened, it's doing a good job, but we expect more.
Yeah.
So that initial impact when they open and shed, that is kind of what shuts animals down. As hunters, we've all seen that. Sometimes you make that just a pure lung shot and they drop. And we didn't hit the CNS.
Right.
That kind of thing, and it's that shock that creates that blood pressure that kind of strokes them out. And we see a lot more of that with our bullet than we'd ever seen with anything else we'd ever shot. More of those instant, or they're so stunned they just can't really move, and then they bleed out, and so less tracking is always great, right?
Yeah, I my first animal I shot with, it was a mule deer last year at it was 420 yards maybe. I was using the 3378. Well, I can't remember what weight bullet we had in that. It was John loaded it up.
I think it was a
No, it was lighter. It was lighter.
170 then.
Well,
maybe
I think it was a 170. I think.
One of the initial bullets we sent you guys just to test with.
Correct. Yeah. So John loaded that up for me. It was a one-shot kill at 400-something yards, and that was my first experience. He walked about ran 20 yards and fell over dead and rolled down the hill.
Very nice.
And it was perfect. And I have some pictures of it, and I think on the backside, where it exited, it was it was a vital, it was a hard shot, and on the backside, it was the damage and the big kind of the big pile of red there. It was the size of a baseball.
Okay.
I would say on the back end. Is that probably pretty typical?
Fairly typical, it varies, but I'd say typically we, with the bullet, it's very rare that we don't pass through, and usually we'll see an exit, I say golf ball, so give or take.
But through the actual hide, it's smaller.
On the entry?
Right.
Entry.
So your meat is a larger one, but on your exit, I found they're a little bit smaller.
It varies.
Right. Okay.
Most of the North American animals are a little thinner skinned, say, than the African animals.
Sure.
And we'll usually see a little bigger hole on the exit on the hide on our animals. You know, the African animals, they'll sometimes be smaller.
Pretty small.
Sometimes on the entrance side, depending on impact velocity and how quick that bullet opens, sometimes we'll see an entrance hole that looks like an exit.
Yep.
And you know, you'll see it. You can see it create that pressure in the animal and actually push stuff out the entrance hole because it's got nowhere to go.
Yeah.
Because it's building all that pressure, and there's
Like
that
a
one hole
cavitation behind it. And
yes, it's made that one hole, and I know one of the first times we saw that his boy shot a deer, and brought it home, and so of course we're geeking out, asking him, which way was it facing, where'd you hit it, and he says, well, this is the entrance, and we both said, well, I don't think he remembers that. That must be the exit, but yeah, sometimes it'll that entrance hole will appear like an exit.
Yeah, when we was in Africa the first time, the wildebeest I shot the first day, same thing.
Yeah,
bubbles and lungs coming out the entrance hole.
Lungs hanging out the entrance hole.
So I shot a wildebeest 2 weeks ago with it. So I shot 2 animals over there, springbuck and a wildebeest. They're both one-shot kills. So I've actually shot 3 animals with the hammer, and I'm batting 1,000 so far in one-shot kills, which is cool. But the entrance hole was bigger than the exit.
Yes.
Yeah.
But it was a one-shot kill on that wildebeest, which they say over there is really tough to kill. And,
the wildebeest tend to run after the shot. We shot 3 wildebeest last April when we went.
Yeah.
He shot 2 and I shot 1.
Uh-huh.
And none of them traveled. I think your golden wildebeest went about 20 yards after shot. And that was with us. Both of us were shooting 6.5s. Well, I take that back. My wildebeest I shot with a 3.75.
Okay.
But,
I shot mine with a 6.5 300, and I know the PH was a little worried, thinking it was undergun. It was a 6.5 300 with 129 hammer, and afterwards he's like, "Oh, okay, well that worked pretty well." I mean, it was 30 yards, and he was telling me before just horror stories about tracking wildebeest for hours upon hours. So now, what one of the questions he was asking, I have had asked about the hammers is, what's funny is they'll say, "Hey, is it?" I have heard maybe they're not as good if you do need to track them. Does it not leave, a blood trail as much? But then the people I've talked to said, but I've yet to ever have to track an animal because it dies. So I don't think you choose your bullet based on the blood trail. You choose your bullet, let's knock them down in the first shot. What do you guys find in when you do need to trail it if a shot wasn't made perfect?
2 holes bleed more than 1. So I'd say generally we see a fairly good blood trail.
Yeah. Okay.
It varies. Sometimes the entrance and the exit are both small. It's a function of
Where'd you hit?
Animal and where did you hit? That kind of thing.
Sure.
But yeah, two holes are better than 1 as far as I'm concerned. You can get blood out of both sides of the animal.
Yeah.
Have you guys? I'm sure then you've tracked animals that weren't hit in a great spot before with hammer bullets. I mean,
we learn more from bad shots than we do from good ones. And unfortunately, I've made a couple bad shots that turned out way better than it should have.
Cool.
I 4 years ago I shot a pretty good mule deer, and I made a poor shot. I missed my shot by 6 inches. He was facing quartering too hard, and I hit just a little bit
too far back.
Too far back. So entrance was at the back of the ribs, exit was out of his ham. And he'd only made it 30 yards if we hadn't bumped him.
Yeah. He pretty much laid down right there.
Yeah, and at the time I didn't know I'd made a bad shot.
Right.
So we just went to go look for him, and shoot, there he is standing there, and then that's when we kind of figured out that that wasn't a very good shot, and he jumped, so we went and sat, and from where he jumped, he only made it another 30 feet.
Oh, no kidding. Yeah.
Yeah, and so my experience with a shot like that in the past is an all-day deal.
Right.
Yeah.
Not good, or if you may not even find them. But. So and I'll try, and that was a little 6 millimeter. Wasn't a big gun or anything like that. But I'll chalk that one up to that initial opening shedding shock
which
just
kind of goes a little bit
like
we were talking last night in the hallway. Goes a little bit again, pairing back to Weatherby. Is there's this trend for heavier, slower.
Yeah.
You know, my grandfather's philosophy in the 40s was let's get things moving faster.
Yes.
How do you, can you guys talk to that and how kind of ultra velocity, if you would, plays into that initial kind of, you know, what we call hydrostatic shock or whatever, you know, the different words are, which
Yep.
kind of has been debunked and then you know, there's some controversy out there, but with your bullets in particular, how do you see velocity, you know, that role playing in it, where if I'm going to use a 6.5300 versus a Creedmoor?
I think that velocity, you know, in a solid copper is king.
Yeah.
The bullet's not going to get torn apart. You cannot tear that bullet apart. Those petals come off, that shank is going to stay.
We get same weight retention, high or low.
All that stuff.
We haven't found an upper speed limit. I mean, we've impacted well over 4,000 feet per second. They just squish a little more.
But you don't see them penciling
Never.
and not opening.
No.
No.
Nope.
Not when they're stable.
No. Yeah. Stability. We talked about that last
Yes.
night.
Yeah.
What do you mean? What do you mean by stability?
You know, so my best analogy of stability is the bullet is like a spinning top. Okay, so a short, fat top doesn't have to spin very fast to stay steady. A tall, skinny top has to spin more RPMs to not be wobbly. And a bullet basically is a spinning top.
Going through the air. Yep.
Yeah. So without enough rotation, then that bullet wobbles or tumbles. You know, and that was, you know, one of the things that we learned in the beginning when we started impact testing bullets was what we call terminal stability. Ballistic stability and terminal stability really are two different things. You know, what it takes to get a bullet to fly through the air or through the atmosphere and stay oriented correctly and accurate is different than what the bullet needs for stability to stay on a straight line penetration after impact. That's a different thing. You know, so ballistically stable may not be terminally stable. You know, so what we would see is a bullet hit and maybe yaw a little bit and not open as it should. You know, and that's where you find those bullets that, you know, look like a banana. You know, that bullet hit and tumbled inside. That's, you know, tumbling bullets can do fair damage, but it's unpredictable. You know,
might not make the path through the animal you want.
That's
yeah,
correct.
I mean, they can go in one side and come back out that side.
Yep.
Yeah.
You know, and do strange things. So when we started impact testing and figured that out, you know, it was a light bulb moment for us. It's like, gosh, you remember that, you know, years ago when we shot that elk and then we found a bullet up in the backstrap. How'd it get there? You know, and things like that. And when we figured out that, you know, the higher, you know, with the all copper bullet, we can't overstabilize one. We have not been able to overspin one yet. Right. I know there's a line somewhere. We haven't found it. You know, we've got a test barrel running a 7 twist in a 375 rum. And so far we haven't been able to get one to slip or anything in that. And accuracy and things like that don't suffer with the high RPMs. But back to that terminal thing, you know, that straight line penetration, we want that bullet to hit and stay on that path. You know, we're aiming for that far leg, right? That far shoulder.
Sure.
And so, you know, on the pure broadside shot, it's much easier. But when you start getting a raking shot, you know, then we've got to have that bullet get to the other side to make sure that we get through those vitals that we need to get to have a good clean kill again. And with that bullet spinning enough, you know, the rotational velocity doesn't really change in flight. You know, the atmospheric pressures change the forward momentum or the forward velocity, but the rotational velocity degrades almost none. Correct. Until it touches something.
Yeah.
As soon as it touches, then that rotational velocity is going to slow down rapidly, right? And so when that bullet opens and sheds and we get rid of those petals, that does what we talked about earlier, but it also makes that retained shank shorter. And so that retained shank doesn't need as much RPMs to stay point oriented as well. Okay. So that retained shank that's nice and square, flat on the front, kind of like the base of the bullet, that's going to stay point on and continue to drive. You know, at some point, every bullet's going to upset and lose its stability and turn. But with that, you know, all of our bullets, we have listed a minimum required twist, and that's based on terminal performance.
Not so much for stabilization.
Not so much for
flight stabilization.
Yeah,
our whole world revolves around terminal.
Yes.
Okay,
And-
that's interesting.
And that's what makes you guys, I think, unique. Correct me if I'm wrong, but in the more lathe-turned bullet market, if you would, of those makers, that you are focused on that while still passionate about accuracy, and I want to get to accuracy in a moment, but you're really focused on the terminal, where would you agree that a lot of people, it's all about accuracy for some, and it's not on that terminal part for more the lathe-turned crowd? Is that what you see?
I don't know. I can't answer for
you don't know what
anybody
everybody else does. Yeah.
Yeah.
Okay.
You know, it's for us though. It's the guiding light. It is the reason for being. You know, and I mean we're in the process of developing a target line, and there it won't matter. You know, if they fly accurate, that's all that matters.
Yeah.
You know, but in the hunting line, which is 98% of what we do now, it's all about terminal.
Yeah.
You know, so if a bullet doesn't do what it's supposed to when it gets there, then there's no point in having it.
Yeah.
You know, and I mean we've chased the BC world, you know, and tried smaller hollow points. We lose some ballistic coefficient because we run a relatively large hollow point open. We've tried tips, and they all of you know, smaller hollow points, tips. They're all inhibitive to terminal performance.
Okay.
We can't get the bullet to open consistently with those things there.
Interesting.
You know, so we won't chase that world if we can't make it work as well as
Sure,
we know
you
it
can
should.
get your BC a little bit higher, but if it doesn't do what it's supposed to do when it hits the animal,
What's the point?
Now, it's trendy and you might sell more because high BCs are in.
Yep.
But at the end of the day, that's not what you're after, is just selling more to chase the high BC crowd. It's you want the bullet to do what it's going to do when it's going to hit. You don't want to sacrifice, you know, a little bit of BC for that.
That's correct.
No,
Yeah.
I don't want.
Yeah.
I don't want the call from a guy who had a bad performance on a game.
Yeah. Yeah. Who just maybe it was a hunt of a lifetime or a draw of a lifetime and gets out there and had bad performance because you gave him a little better BC.
Yeah.
So,
Yeah.
yeah.
So Adam was joking a little bit about our ballistics team. We think that are sponsored by you guys, but I don't think they are.
I give him a paycheck, I'm pretty sure. It doesn't say Hammer on it.
But one of the things they always say is they're like, the Hammer bullets will just always shoot. You know, sometimes a certain barrel and a certain bullet, they just won't like each other.
Yeah.
But we've found that your Hammer bullets seem to be a little less picky, if not a lot less picky than other.
The
things
accuracy
we
we found has been phenomenal.
Yeah.
So what do
Thank
you what do you yeah, no, it really has. What do you attribute that to?
Oh, divine intervention.
A whole lot of work and a whole lot of God.
I'd rather be lucky than good, right?
Yeah, you know, a lot of work and a lot of God. You know, we came up with our drive band design. You know, and that was, you know, part of our story.
Elaborate on what that drive band design is.
The bearing surface on there. I don't know if we can see that.
We're
in the
looking at a
camera.
bullet if you're listening on audio.
So you got looks like 5 annular rings there.
Yeah.
Okay.
So we're not the first ones to come up with a drive band.
No.
Okay.
You know, that technology's been around for quite a while. We were the first ones to come up with a drive band that is radiused.
Yeah.
Okay? So if you look close, you can see the drive bands are on a curve. They radius down and they radius up.
Okay.
So there's no flat spot anywhere on the bearing surface.
Okay.
So
My eyes are getting bad.
yeah,
I'm going to trust you on it.
yeah, yeah. But
Got the readers.
yeah, stupid things. So anyway, you know what that when we designed that, what we were after, two things. One, you know, we didn't want to step on anybody else's patent.
Of course.
You know, and two, the copper bullet issue that's always been out there of poor accuracy in loose barrels, high pressure in tight barrels. and then the ones in the middle that are on spec, they work great, right? And so we were out to solve that issue because copper is not as soft as lead, so it doesn't. This is a hard word, obturate. You know, so the lead
Conform
bullet,
to the
Okay, we've really gone deep now. We just said obturate.
Yeah, somebody can probably correct me. I probably said it wrong. But so, you know, in a loose bore, the pressure of the charge will hit that lead core bullet and cause it to swell and seal the
And
bore.
stay tight in the rifling.
And then, you know, so then your accuracy, velocity, all that stuff's good. You know, and then the lead, you know, in a tight bore will ring down or squish down and pop through without excessive pressure issues.
Right.
Well, copper won't do that. It's not soft enough. So with the radius design, so if you think about a radius, the outside diameter of that radius, the ring around the bullet, is very finite in the amount of material that's actually making that contact. So it enables us to make our bullet bigger than caliber without creating any pressure issues. So in the end, we seal the loose bore and get good accuracy, but don't have any overpressure issues on tight ones. Okay.
So there's more consistency across barrels.
Yeah. You know, so in that design, out comes this weird inherent accuracy. You know, when we first started, you know, I was the lone guy out there saying, "Hey, look what we did." You know, and so I would post up things that we did. You know, we loaded this, we did that, and gosh, we load developed, and we were done in 12 shots. We had it zeroed. It's shooting half MOA. You know, and I used to get well, you just got lucky. And I'd say, well, you might be right. You know, and then eventually I got that, and I was like, well, you know what? I get lucky all the time. So
it almost might be good at that point.
Yeah. So then it was, you know, then we started realizing, hey, okay, these things are easier to load than anything we've ever loaded before.
Yeah.
But in all honesty, we didn't know why. You know, and so, and I'm still not exactly sure, other than it has to do with these drive bands.
It has to do with the radiuses. Everything is eased into the rifling where a lot of the drive bands are square.
You know, and
then it's an abrupt.
More drag or
it's abrupt. It's more harder going into the rifling. This here has super easy, consistent.
They consistently,
engraving.
Cleanly release from the barrel, same all the time. And I, you know, for lack of better words, I call them like shock absorbers. You know, it's so finite in the amount of material on the outside diameter of the bullet that's making contact that it's soft. It's easy as it engraves. It's easy as it goes through.
And then what about your tolerances too on a lathe turn bullet? If you could speak to that versus traditional.
The lathes we run are super accurate. We hold 2 10,000ths. So, you know, on a 308 caliber bullet, we cut them 308.5. So tolerance would be 308.6 down to 308.4. Very tight.
Wow.
Very tight.
0.0002 inches.
Right. And that's going to be a heck of a lot tighter than your ones that are coming off your more traditional presses.
A lot.
Yes.
Yeah.
Like a lot.
Yep.
Yeah.
Which
also probably leads to
and their lathe turn, they're round. They're
yes.
concentric.
Right. So they're more concentric, tighter tolerances, and that's why you get, I'm just speaking of those that don't understand the difference between the two. Correct.
And accuracy.
Yeah. So with consistency comes accuracy.
Sure. Absolutely.
You know, so there's consistency in the manufacturing, and then there's that inherent accuracy that comes from the design. You know, and like I said earlier, you know, we kid about it, but I really do give that glory to God. We are not that smart. You know, I mean, we come up with some pretty good ideas, but you know, that was a side effect. This accuracy was a side effect of what we came up with to solve the pressure issue. And so I'd like to take credit for it, but we really can't.
Yeah. Well, that's so cool because, I mean, what really has drawn us to the bullets initially before we did a lot of testing in the field on game was the consistent accuracy. Yeah. And that's what our ballisticians kept telling us. In fact, we have a little tight group that Keaton, another one of the ballisticians, did out at out at the ranch here. We got some steel, and it was at 600 yards, and they were, it was touching.
Yeah.
It was out of a 270, and it was, they just started falling in love with the accuracy before we'd hunted with them. Then we started dropping stuff on the hunts,
I
going,
shot an elk last year.
Okay, yeah. Did you kill some stuff with the hammer?
I did.
Yeah.
Elk. It was 350 or so.
Okay.
And I think it did have one pedal left on it.
Yeah.
And I
That's not what we want, but it happens.
it was kind of a steep angle. I don't know if
Yeah.
that had anything to do with it, but it was standing dead. It was a good shot, but I shot it a second time because we were in some crazy country in Idaho.
elk.
And
Yeah.
did not, if it's
right.
still on its feet, I'm
You
going to
put
put
it
another
on
one
there.
in.
Oh, yeah.
So
No,
Heck yeah.
that's a good hunter.
the second one, it just dropped straight down,
Yeah.
just instant.
Yeah.
But CNS shot right kind of base of the neck.
Yeah, my son actually used the hammer out of the 3370 for his first elk last year. I forgot about
cool.
that. So although it wasn't me pulling the trigger, I was out there. Now, because I'd taken him many, many times and he'd had the elk that always got away, never shot, and for a few different years, he unloaded the magazine on it because he was paranoid about not getting his elk. So but I forgot. It was some great results too with his elk. It was maybe 250.
The wound channel on this bull that I shot was wicked.
Yeah.
It was wicked.
Yeah, and that's what we've been talking about. That's what we're after.
That's that square front.
Yeah.
Yep.
It turns the lungs to mush, and that's just all that pressure going out so fast
Yep.
off of that square shank.
And those, back to that, those shed pedals,
They do it too.
we discounted them entirely when we first started. We didn't even think about them. We just knew we wanted them off. But and with the copper that we use, it makes a difference on what those pedals do as well. But those pedals tend to track with that retained shank, and often we'll see an exit with 3 or 4 little holes around it where those pedals exited.
The main part of the bullet was in the opposite hide, and there were 2 pedals right next to it. There's one pedal I did not find, but it was just like they were within an inch and a half.
Yeah. And so that also widens that permanent wound channel when you've got 3 or 4 other little projectiles running along with it. It takes our wound channel from here to here.
Is there anything to like a better vapor trail with your bullet?
The hammer trail.
Yeah, the hammer trail. So we decided that we just needed to own it.
I've seen a couple videos, and even the video, I've got my elk shot on camera, and it's kind of like nuts.
It is, and it really shows up on camera.
Why?
Yeah. Again, they don't know this
They
one
don't
either.
know?
They just
No.
keep getting lucky. Haven't you realized it?
we used to chalk it up to residual oil.
On the bullet or in the hollow point.
But now, since our relationship, we've started,
we were a pain in the butt and made you clean it out.
concentrated on cleaning these things up, and so it's not the oil. Well, then we started looking at that too. Well, it can't be the oil. The flash point on the oil is like 585 degrees. So
That bullet doesn't get that hot.
I don't think we can make a bullet get that hot in flight
Not
to
that
cause
fast.
to cause the oil to burn off. We've got to do more testing on it. But anyway, it does show up more on some days than others. So it's an atmospheric thing.
Well, that's all vapor trails. That's true of, but
and so I had a guy describing it for me the other day and how he kind of figured it, and I think his description was good. He talked about it like an airplane as it passes through the atmosphere, and it makes that moisture in the air condense behind it and create that trail. And I think the drive band design here is creating
Disturbing
that
the air.
turbulence, which is creating that trail.
Yeah.
So it's ours. It's a hammer trail.
it's a hammer trail. It's substantially
It is.
more visible.
You can spot a lot of shots with a naked eye.
Yep.
Because you can see them. You can see them go.
It's wild.
Yeah, I saw a couple of those videos, and the vapor trail.
I thought you were putting like some special loads where like you put all the gunpowder in, and
it's
then
a
maybe at the
secret.
very top you put some like baby powder or
Right.
something. I don't know what was going on.
It's a trade secret, and we're really not going to let it out.
Yeah, because you don't know.
Maybe we should do a little editing here and just say, we don't want to talk about it.
I'm leaving it in.
Well, the good news is nobody can copy you if you don't even know what you're doing.
Yeah. So it's there, and it's neat.
Yeah. Now, one of the other things to talk about, we've been talking about differentiators. So we got a good vapor trail, we got phenomenal accuracy, we got good penetration. One of the differentiators is Hammer bullets isn't the cheapest, and we just need to put that out there. Now,
it's the nature of the process.
Sure, but if you could maybe speak to that for our customers, go look. Okay, well, I've seen maybe listen to this podcast. We have it in a variety of Weatherby loads, and that's growing. We're testing more and more, and so you're certainly going to see more calibers, different more bullet weights, with these Hammer bullets across the Weatherby line. But they're going to look at it compared to maybe some other bullets, even other all copper bullets we offer, and it's going to be more expensive. Now, it's not because Weatherby's gouging them. No. You charge me more, Steve.
I do.
And so maybe speak to the customer to let them know, obviously quality, costs more, but why does this process in this bullet, why would I expect to pay a little bit more?
Well, material costs are higher, but really in the end, that's not the significant driver to the end cost. We could use cheaper copper that costs half as much, literally. We could cut our copper costs in half. But still, when it comes down to that individual bullet, the difference in cost of copper is fairly insignificant.
It's time, isn't it?
It's time. It takes. Our machining process is ironed out quite well, and it still takes 25 seconds to produce a bullet on a machine. And still we have handling time after that. They still got to get washed. They still got to get packed. That stuff still has to happen. But that time it takes to produce, compared to other conventional bullets out there that produce 20 times that fast. They're coming out in seconds or fractions of a second, per bullet. It's the time. If we could make them faster, we could make them less expensive.
Sure. But your tolerance right now with today's technology, your tolerances and consistency, as we spoke of, would not be as tight. So you could sacrifice material properties, which would be performance, and you would sacrifice right now to get it faster. You would sacrifice both those tolerances potentially, as well as the consistency in them, which could affect terminal performance and/or accuracy.
And they might be rough.
We could increase the
feed rate, but the bullet's going to get rough.
They get rough. It's a premium product. We want it needs to look premium.
That's right.
Whether or not it would affect its ability to work,
probably
I don't think so. But it's. I don't want it to not look good. Weatherby rifles got to look good too, right?
Absolutely.
And so it's got to be a good-looking product. And we could run in the dark and pay less attention to our tolerances, and go, it's pretty close. Box them up. You just can't do it. And that falls in that same category. It's a premium product. And it's a premium price product.
Sure.
But we can't have one without the other.
Sure. But coming back to kind of the Weatherby partnership, let's say you drop a couple grand on a Mark V. You're not buying a $400 rifle. You're buying a nice rifle. You're buying it, let's say, in a Weatherby cartridge. You're buying it 6.5300. Now we know you like speed. We know you like performance. We know you like quality, and you've spent something on your rifle, and to balk it a little bit on that ammo at the final part, and maybe what you spend both time and resources wise to go on a hunt, it's there. Now, sure, am I going to go and plink all day with a Hammer bullet? You guys would love them to, but it's probably just not a great idea.
That's correct.
But for the end game of what we're going for here, it is, I think, a pretty good complete package.
It is, we talk about that a lot. The price conversation comes up, but. It's funny, you talk about that, you got thousands of dollars into your rifle and scope, and then you're driving an $80,000 pickup, and you got a $500 camouflage suit, and you got all this stuff, and then a guy doesn't want to pay $1 for a bullet. It almost doesn't add up. No. And really, in the end of all the planning and everything you're going to do to go make this hunt, as soon as the trigger pulls, the end result relies on that.
Yeah.
And if that doesn't do the job that it should, then all of it might not be the experience you want.
Yeah.
I think it's a pretty awesome partnership with we make guns that go really fast. You make bullets that like to go fast consistently. Open up, hammer trail.
Yeah. Well, you know, and you know, I've invoked Roy's name for a long time, long before we had a relationship. You know, I've said, you know, I think we make Roy smile. You know, I mean, you know, and that discussion comes up. They don't need speed to work. You know, that's another myth. Yeah, that's a good word for it. You know, the copper bullet needs speed. Well, I can say ours does not need speed. It's capable of speed. There's two different things.
Yeah,
they work very well at low velocity or mild cartridges. You know, but when you've got a race car and you want to run top fuel in it, these guys will do it. You know, I mean, and you guys have seen in your ballistic testing. You know, we see typically, you know, out of our standard hammer hunter, like what you guys are loading, 50 to 100 feet more than you would typically see out of a bullet that weight. They're capable. You know, the engraving pressure is a little lower, which allows you to hit it with a little more powder, and your end net result is a little more velocity than you can get out of a typical bullet. You know, and then, you know, from the Weatherby world, you know, they're capable of handling the Weatherby velocities, you know, getting up into those velocities that are, you know, 35, 36, 3,700 feet per second.
Yeah.
We don't have any issues with bullets coming undone in flight because there's nothing to come undone. It's
That's
one
correct.
piece. You know, we don't have any issues with, okay, we got all that velocity, but we have that pop-up close-range shot of that bullet coming undone on impact. You know, that was a terrible problem years ago. You know, so the solution was always to run heavier for caliber bullets because, one, it would slow down that initial velocity so it would survive the launch, and two, you'd have enough bullet left after impact that hopefully you get penetration.
Right.
No issues with penetration or launch speeds. Why not go get the speed? Because it kills.
Right.
It works really good.
Yeah. Preach it. Preach
That's
it,
right.
Steve.
That's right. So we're loading a variety of cartridges, like Adam mentioned, and you can buy finished cartridges from us. And you guys, how can people find out more about you?
Oh, well,
Website.
Yeah, our website, you know,
Or call us.
hammerbullets.com.
Yep.
You know, both Bryan and I's phone numbers are on the top of the page. You know, we've
You
made,
sure that's a good idea?
I don't know.
Some days not.
You know,
Luke, don't put mine on Weatherby's, okay?
you know, well, we kind of vowed when we started, you know, that we are going to make sure as best we can that we have time to talk to people when they call.
Cool.
You know,
That's awesome.
You know, and
cool.
Making sure that we continue to have that time is part of our business model. We'll make sure the stuff gets done in the manufacturing end, but we've got to make sure that we have the time to talk.
That's cool.
Yeah.
No, we so appreciate it. And I think we resonate, you know, although you guys are newer than us, you know, it's, but it's still to see, you know, it really came out of your passion. This wasn't, hey, I'm going to go get a bunch of venture capitalists, dump a bunch of money in because I think I can make money. This came out of your passion, much as it did my grandfather's when he wounded an animal in the 40s and said, you know what, I want to get bullets moving faster, and that's why we're here. So when it comes out of a need, a passion, you know, businesses tend to thrive. It's not just a formula. It truly is that passion drives what you guys are doing, and you're not compromising. And I think, you know, that we resonate with that, and we appreciate it.
Yeah, that's.
I mean, quality is our number one thing. And then, you know, terminal performance, but we
Terminal
won't let a
performance
product go out the
quality.
door that doesn't meet our standards,
It's
which is pretty high.
yeah. You know, I mean, we're just particular. You know, we were that way in our previous businesses, and we're going to stay that way here. You know, we won't sacrifice. You know, not. No, you know, we started this thing without any money.
Yeah.
It's hard to do.
It is.
It was been a tough road.
It was a very tough road. You know, but we worked through it. You know, and we talked about at one time, you know, maybe we should look into an investor.
We talked about it.
You know, and I'm so glad we didn't. You know, I mean, we have grown at the right pace.
Yes.
You know, we look back at it. You know, and you know, a lot of that kind of stuff. You know, if we'd have known, we wouldn't have tried, right? You know, if we'd have known that, we'd have never done this. But, you know, if we could start over and do it again, I don't think we'd change it. Because I don't think if we'd have had venture capital
Mm-hmm.
or whatever.
Mm-hmm.
You know, I think we would have grown fast, and we would have failed by now.
Yep.
I think
We've made quite a few changes that have.
we'd have made mistakes that we couldn't recover
That's
from.
right.
You know, so the hard road, it's been the right road.
Cool.
Yeah.
Great story, guys. We really appreciate you
Yeah.
coming and sharing a little bit and being open and honest. Starting with no money is hard to do, and you guys have appeared from the outside looking in to have done an awesome job. So
Yeah.
I appreciate it.
Yeah,
Thank you.
thank you.
Yeah, it
We're here to stay now.
yeah.
Yeah.
You know, it's a hard thing to say as an entrepreneur that you made it.
Right.
It's still really difficult to say, but I feel like we have to really screw it up now to.
Yeah.
We really got to do something wrong now.
Yeah.
it's great.
You know, so
Cool.
the snowball's starting to roll itself.
Good.
Yeah.
That's
Yeah.
cool. Well, good.
Cool. Well,
Glad to be a part of it with you guys. And
Well, yeah,
Yeah,
I think
fun.
we're a great fit.
Yep.
Yeah,
We said
absolutely.
that from the start. You know, when John first called, I said, hey, I think maybe we might be able to work with these guys.
Mhm. Cool.
You know, and especially now after visiting today,
Cool.
Yeah.
It's good.
seeing the operation,
Good.
you got a class act here.
Good.
cool.
Thanks.
Well, you
Appreciate
guys
it,
keep
guys.
up the good work.
Thank you.